Okay, let's talk about insertion sort. I'm not going to talk about the main method or the print array method because, I mean, I'll show them to you, but they're the same methods pretty much we use for selection sort. So here is our print array, our insertion sort, and then print arrays. This is very similar to how we did it with our previous method. Our print array thing is the same. So I really just want to talk about insertion sort. Effectively, we take the first value from the unsorted portion of the array. So basically, we count the first index as sorted when we start this array. And then we look at the first value and we ask ourselves the question, is that second value in the array smaller than the first value? If it is, we just swap them. As we go to the next value, we ask ourselves the question, where does that fit? Is it fit at the beginning or in the middle? And we move it to that position. Let me show you what that looks like. Well, let's just talk about what that looks like here. This is us taking that current element, which is array 1, and then we take, which array I, sorry, and then we take j and we say j is equal to I minus 1, and if j is less than negative 1, or when j is less than negative 1 and the array at j is greater than the current element, we basically set j plus 1 equal to array at j. So we just test through to find out exactly which position we're going to put that particular thing at, and then we put them in and just kind of stick it in the array. So that's kind of how that looks. And let me show you what that looks like when I run this program. And this is what it looks like. So this is the original array. This is randomly generated. We have these values. 92, we consider that the sorted part of the array, and then we look at 33. Is 33 less than 92? It is, so we just swap them. Go to the third position, we look at 19, and we say 19 is smaller than both of those, so we put 19 in the front of the array. And then we go to 4, right? So now it says 1932, 1933, 92. We go to 4. 4 is actually smaller than all of that, so we stick that in front of the array. We go to 17. We found out 17 belongs in front of 19, so we put it there. And so forth and so on until we get to the end of the sorting process, and we found out in this case there were 14 iterations and 8 passes. Okay, I'm going to run this again just so you guys can see a different one. We have 16 iterations with 8 passes. I'm going to run it again. We have 10 iterations and 8 passes. That's to do with how sorted the array is. We're just going to run this again. We can run this a bunch of times. 15 iterations with 10 passes. 18 iterations with 8 passes. 12 iterations. Sometimes I'll end up with an array that is, in fact, let's go ahead and test something. I'm going to go to selection sort real quick. And I'm going to set this array to be a size of 100. Now, selection sort is very standard. It's always going to give us the same number of iterations, and I'll kind of show that to you right now. I didn't mean to do that down here. Let's go ahead and compile that, and we'll run it. All right, and so we have 95 swaps with 4,950 iterations here, right? And for insertion sort, we're going to do the same thing with 100 elements, and we'll see how many iterations we have. That's the wrong thing. All right. Here we go. Nope, I didn't save this. Let's save this and compile it. All right. So now we have 2,171 iterations. I mean, we keep seeing insertion sort running more efficiently than selection sort. We'll have to, we could do more research into that, but sometimes insertion sort will be less efficient depending on the moment. Right, let's go ahead and run this a few more times just for fun. All right. Yeah, it keeps giving us a similar results. Anyway, um, yeah. So you guys see insertion sort and what that looks like. The homework expects you to do bubble sort, so please implement a bubble sort the way it was mentioned in the homework, and we'll stop the recording here.